Today I'd like to introduce you to Matt Ayre. He's been with us at the Arctic Institute as a postdoc since January of this year. He completed his PhD at the University of Sunderland in the UK, and his work focuses on researching Arctic climate through time, its changes, by compiling climate data from logbooks of British and American whalers. The logbooks contain observations of weather and ice conditions, flora and fauna, and he's made ice observations himself on board an American icebreaker in the Beaufort Sea, and compared these to the terminology used to describe these conditions to those that have shown up in the records. And since joining us, he has gathered another 140 logbooks and brought them back to the Institute, and that's growing as he and I will both head off soon to gather some more. And he'll be able to tell you a little bit more about them, but certainly the next job with all of these logbooks is to transcribe them in order to get the information that we need. And his talk is going to give you a sense of the depth and the value of this kind of research. So, take it away.
Thanks, Patty. It's a slightly strange title for this talk. I've never used this one before. But this quote, I liked it so much, I found it in a whaling logbook. It was penned 196 years ago on Friday the 13th of April in 1821 by Captain Munro of the Neptune sailing out of Hull. Hull is a city on the east coast of England, which for the past 5 years has been voted Britain's worst city. However, it used to be very nice in the past, and if you do ever visit, you can tell. So what of course it's got to do with climate change? I'm not really into my fashion too much, but hopefully by the end of this, I'll be able to tell you what they do. So, as Patty said, my research is focused on the Arctic and the Arctic climate, but why bother? Why is the Arctic important? Most of you should know the Arctic's on the top of the world. It's a large ocean, generally surrounded by land, and it's dominated by sea ice. Sea ice is pretty important, not just to the Arctic, but to the global climate. First of all, it acts as a giant mirror, reflecting a great deal of incoming solar radiation, up to about 90%. And also, so you've got that here, you can see it bouncing off. And also the formation of sea ice, when sea freezes, the salt drops out of it, and this creates this really dense, briny, cold water, which sinks down into the deep ocean and drives the thermohaline circulation, which is sitting in the corner here, which is a very slow-moving ocean-wide circulation, which serves to try and equalize the balance of heat between the equator and the poles. Without which, the climate would be pretty different to what it is today. If the thermohaline circulation didn't exist, Europe wouldn't be quite warm. I certainly noticed the difference of the Gulf Stream moving here. So I got off the plane in January and it was minus 30. That's quite far removed from the plus 2 or 3 degrees I'm used to in winter. So the Arctic's not only important for global climate, it's important in its own right as an ecosystem. It harbors a wide variety of unique species and communities as well. So there's this famous picture of the polar bear clinging onto the last little bit of ice. But you've got Arctic communities that rely on the sea ice for subsistence hunting and their way of life. But what happens if the ice melts? So this snippet of graph in the top corner here, that's the overall sea ice extent in September, which is the month in which the sea ice reaches its minimum extent after melting all summer. That's from 1979 until present. And as you can see, there's fairly rapid continual decline. So what happens when the ice disappears? Aside from all these climatological effects, it opens up new opportunities for resource exploitation, also for shipping as well, and tourism, which is a new one. In fact, Patty's off through the Northwest Passage soon on a cruise yacht, which is pretty cool. But that's something that would be unheard of 20, 30 years ago. You just couldn't do it because of the ice. Also, because of this, it's called the albedo, which is the reflectivity of the sea ice. As more ice melts, though, you get into this negative feedback loop, which exposes more ocean. Ocean absorbs more heat from incoming solar radiation, therefore melts more ice, and you get stuck into this loop. So at the moment, sea ice is looking to continue downtrend, and by 2050, there's predictions of an ice-free Arctic summer. Which brings me to this little graphic in the center there. This is a phenomenon known as polar amplification. So because of this negative feedback effect, global warming's about twice as prevalent in the Arctic as it is anywhere else in the world. So while the rest of the world is coming up to 1 degree warmer, overall, the Arctic's over 2. But how do we know this is normal? This is exceptional? Is this normal? Well, we have to look back into the past. So there's a number of ways we can do this. So I mentioned from 1979 until present, we've witnessed this massive decrease in Arctic sea ice. That's been measured by satellites. This is Cryosat-3, I believe, which has been taking photographs from space of the Arctic since 1979 and continues today and will continue for the foreseeable future. However, 40 years isn't nearly 50 now. That's still not really a long time climatologically, and it's been changing so fast. But for something so important to the global climate, how do we know how to put this in context? It's it's a bit of a funny question. There's such weight put on Arctic sea ice decline. But then you go back and you say, okay, 50 years, well, what was it like before that? When was it stable? We don't really know. And there's a number of ways scientists can look into figuring that out. So prior to satellites, you had plane-based surveys. So there's a bit of a wing in there somewhere. And ship surveys. So, but really, you push them back to about World War II. So mid-20th century. Prior to that, the Danish were pretty good at making maps, certainly around Greenland. So we have these maps of sea ice edge positions that take us back to 1900 almost. But prior to that, nothing. It kind of goes cold. So you have to look to things called proxy records, so naturally recorded phenomena that can tell you about sea ice. So some people have used driftwood, dated driftwood that's been ice rafted up on the land, as an indication of when sea ice was more extensive, and you can date the wood. But it's not really concrete in any way. It can tell you a single place and a single time, but you have to rely on the driftwood having stayed there for over 150 years. So you can look for things, so we can take cores from the ocean floor, and you can do a couple of things with them. One, you can count foraminiferal fossils, which live predominantly on the sea ice edge. So certain species which will feed on the algae which grows on the edge of the sea ice. And when that melts, they die, and their little shells sink down into the ocean floor. And we can take a core of the ocean floor, carbon date the layers, and count how many are in there, or if there's any at all. And that begins to give you an indication of where the sea ice was. Alternatively, they also leave a biochemical signature. So I'm no chemist, but this is the IP25 sea ice biomarker, which was fairly recently developed. And again, found in ocean cores. Ocean cores are fantastic. Like, you can go back hundreds of thousands of years, albeit in a single place, but we can take many. Problem is their resolution. The very, very best ocean cores in the quietest, most unturbulent parts of the ocean in the Arctic will give you, at best, probably a decadal resolution. So from this, we can say there was ice here within this decade or not. But more likely, and certainly the longer-term records from the open ocean, talking 50 to century scales, so one observation every 100 years, which is great for a long-term analysis, but when sea ice is changing so rapidly, it kind of doesn't compare. So we need to look, or ideally there needs to be a way to look back at the history of sea ice at the same kind of resolution that we get today, so daily. And one of the ways we can do that is with the Arctic whaling trade. So before I go into the Arctic whaling trade, I'd like to give you a bit of history about whaling so you know where it comes from. So whales are pretty important resources. They're fairly big and fatty, and their fat contains a lot of oil, which rendered down. You can render it down, and you're left with oil, which can be lit, can be used as lubrication, and a variety of other uses. This was fairly obvious to most communities way back to the Mesolithic. There's a petroglyph from Norway, I believe, which was meant to be a pilot whale. If it's important enough to spend the time carving it on a rock wall, it's probably fairly important to society back then. This is a bowl from Skara Brae in Orkney. This dates back to the Neolithic. And this was made from a whale vertebra. And then you have, I don't know, some of you may recognize this. This is the Grindhap that happens on the Faroe Islands. It's a pilot whale drive. It's a very simple way of catching whales. And most, things like the Skara Brae bowl are probably due to beached whales. It happens fairly regularly wherever whales occur. But the Grindhap's really kind of the first method of actively hunting whales. And it happened, there's the Lewis chessmen from the Hebrides. It happened in the Hebrides right up until the turn of the 20th century. It's now only the Faroese that continue to do it. But it was really the Basques that were the first commercial whale hunters. And we're in the Bay of Biscay here. And they were hunting something a whale known as the Biscay bowhead. This whale's now extinct. They hunt it extinction. But they pretty much started this around the 12th century. And Europe as a whole became fairly familiar with the uses of whale oil and fairly dependent on it. It's the only form of oil at the time. We didn't have grain oil. So animal-based oils was the only way. And there was certainly no crude oil or any fossil fuel-based stuff. So about 12th century this started. And it didn't take that long, 200-300 years before the Biscay bowhead was extinct and no longer find it. And the Basques journeyed all the way over to Newfoundland, where they found the larger cousin of the Biscay bowhead, which is the Balena mysticetus, the Arctic bowhead that we know today, and also the northern right whale. And they whaled on Newfoundland for a good couple hundred years, and here's one of the recovered whale boats they had. They were fairly advanced. So Europe was pretty into its whale oil now, but it was running out. It was hard to get to. You know, the Basques were going all the way over Newfoundland, but they can't bring back that much, only in small boats. And then the Dutch explorer William Brandt, he was searching for a northeast passage to trade with China, or Cathay as it was known at the time. And he discovered the islands of Svalbard, known as Spitsbergen back then. And he published this map, of which there is actually an original for sale. And I did ask my boss if I could buy it for the office. It was only $78,500 US. She said sure, so hopefully it'll arrive any day now. But as you can see, it's a beautiful map. But you can see all these whales everywhere. And the sea was literally teeming with them. So he came back to Europe and he published a pamphlet that said, look at all these whales, you know, I've discovered this new resource, which was probably a slightly stupid thing to do. He should have kind of kept it to himself, or at least within his country. And the recent, that's a bit loud. So if I go back to England, so William Brandt has told everyone that there's these whales in the Arctic and Europe was wanting whale oil. There was a company known as the Company of Merchant Adventurers to New Lands, which was founded by Sebastian Cabot and Sir Hugh Willoughby. So you may have heard of some of those names. They're fairly famous in terms of exploration. That eventually became the Muscovy Company because, frankly, they were terrible at whaling. But they heard about this, and they sent 2 ships off up to the Arctic, employing some Basque harpooners, because the Basques had been doing this for 300-400 years by this point. They were pretty adept at harpooning whales. So they got there, and they were terrible at it. They both got caught in the ice, and their ships got wrecked. Thankfully, there was 2 interlopers from Hull, that lovely place I mentioned before, which came. They'd also caught wind of this and gone up as well, and managed to rescue them. But on the whole, the country wasn't particularly successful in whaling, and it made a huge loss. It's a pretty risky endeavor. You spend the equivalent of millions on a ship, send it up to the Arctic for it to possibly be crushed, for your crew possibly to freeze to death or get scurvy and die, and you may not catch anything at all. You don't really know what you're doing. The Dutch, however, were pretty good at it, and while England kind of continued and sent the odd investigatory trip up there to see if they could procure it, it was really the Dutch that took to it. And by 1650, they pretty much had a monopoly on the trade. They were sending, between 1650 and 1750, they were sending upwards of 1,000 boats up a year to hunt the bowhead whale. So I want to talk about the bowhead whale in question for a moment. So it's the largest marine creature in the Arctic, the largest marine mammal. It's possibly the oldest living mammal on the planet. It's quite hard to tell unless you kill them, and then it's no longer alive. The bowhead's pretty unique. They grow up to about 70 feet long, and they can have up to 6 feet of blubber. They live in the Arctic all year round, and this is kind of a key point to my research. So they live in the Arctic year round, and you can see in the center here, this light blue patch, this is their distribution, which matches really closely to the sea ice maximum and minimum, which is because they follow the sea ice melt as it melts back, and then they come further south as it extends in the winter. And this is because they're filter feeders. They feed on plankton, which blooms on the ice edge because of the algae there. So if you know where the bowheads are, you kind of know where the sea ice is. So suddenly these whalers become a really good indication as to what the ice was like in the past. I said they're the oldest living mammals. You can date them via their eyes. So they were hunted almost to extinction by 1900. Hunting on them was banned in 1946, I believe, but there's still some subsistence hunters in traditional communities up. So the Inupiat, Point Barrow and north coast of Alaska, they catch between 5 and 10 a year, and it's fairly central to their diet. In some of the bowheads they've found stone harpoon heads inside the blubber, and these weren't really used post-1850. With the advent of Europeans colonizing up in the Arctic and exploiting the whales, the communities up there took advantage of steel harpoon heads and so stopped using stone ones. So yeah, they're pretty old. So now we have this marker of sea ice with the bowhead whale. So we need to talk about British involvement in whaling. I said the Dutch dominated up till 1750, which is great. The UK loved to be at war with the Dutch, six or seven times. My history's not that great. But we were constantly relying on buying whale oil from Europe, mainly the Dutch, because it was used for all sorts. The Industrial Revolution's kind of in its infancy at the moment. We're starting to become urbanized and mechanized very slightly. And whale oil is becoming extremely useful. So you could use it to lubricate machines. It was used predominantly for street lighting, later for soap. You could treat fabrics with it. What else could you do? It started the bottle gas industry eventually. So Britain was really keen on getting its own whale oil. It was sick of buying from the Dutch. Every time we're at war, you can't get any. So this guy here, Robert Walpole, he was Prime Minister between 1721 and 1742. and he decided to start a bounty to encourage the whaling trade in the Arctic. So in 1733, he said, the government will pay 10 shillings per ton of displacement of boat that goes up to the Arctic and hunts for whales. Most whaling boats were between 200 and 400 tons. That's a pretty good deal. You go up, you don't even have to catch anything when the government are going to give you some money. But it's still pretty risky, so no one really bothered. It was raised to 30 shillings per ton, and a couple of people kind of got interested. And then in 1749, it was raised to 40 shillings per ton, and practically every port in England went, that's a good idea. You know, this can practically be profitable even if we don't catch anything. One of the key points about getting the bounty was you had to produce a logbook back at customs when you returned from your voyage. Now, the keeping of a logbook was fairly standardized by then because it's a navigational necessity. However, the government, when they released the bounty, said you need to record the wind direction, the wind strength, the weather, ice, any whales caught, anything else that happened. And you have to show this in customs. So this now makes them into quasi-official documents. They're still owners. They're still owned by the ship owner or the captain, but they've got some sort of official significance now, which helps to ensure their survival. So the Royal Navy kept logbooks throughout practically its whole history. And there's over 100,000 sat in the National Archives at Kew in London, which is a whole load of weather data. So, however, with whaling, you just don't get that. So the bounty helped ensured it. So where are we going? So where did they go? I mentioned they went up to the Arctic and they went to Svalbard. So yeah, they'd come up mainly from the East Coast, and they'd sail up to Arctic and follow the sea ice edge, and they'd probably arrive around April and leave about September, which is about the sea ice melt season. So here you've got this indication what the sea ice is doing. One of the byproducts, come back, there we go. One of the byproducts from catching the bowhead whale, apart from the blubber, which was the main source of oil, was the baleen. And this is the long, fibrous material that's in the mouth of the bowhead that they use to filter out plankton from the water. And it's kind of like, I guess the easiest way to describe it is it's kind of like fiberglass. It's got some spring to it. And one of its predominant uses was corsets for the stays. They also used it in petticoats and in umbrellas and other decorative items. But predominantly, it was used in women's fashion in the 18th and 19th centuries. And it was so popular, in fact, it commanded such a high price, it kept the trade buoyant at times when whale oil was low, or the price of oil was low. So I mentioned they'd gone up to Svalbard and been whaling, but they've been whaling there since 1600 pretty much. And practically all the bowheads that lived there were now gone. It was very difficult to make any profit. Catches were really low. And people have started to experiment crossing the Atlantic and going up into the Davis Straits and into Baffin Bay. And this is my area that I really look at. So from about 1830, from 1810, the trade shifted fundamentally from Svalbard over into the Davis Straits. And it continued there up until the advent of the First World War. So there was around 6,000 whaling voyages in total between 1750 and World War I. Of those 6,000, about 300 logbooks survive. So not many. And of those 300, only about 150 of them survive for the Davis Straits. There may be many more in people's houses. I was in the UK a couple of weeks back looking for more logbooks, and I turned up to an archive and they handed me a huge box that someone had recently donated, they haven't even gone through, which had 40 logbooks in it. They weren't whaling, unfortunately, but it was nice. But they're out there somewhere, some of them. Most of them will be lost. But what's really interesting about them is their daily entries of weather. So I'm going to try and read this one out to you. So this is the Tuesday, 30th of May, 1820. So the second column in there, they always put this is wind direction. So it's variable. Light airs and hazy. At 5 p.m., finish making off the blubber. So when they caught a whale, they'd flense it. So they'd bring it alongside the ship, and then they'd peel it, essentially, in these huge, great big blocks of blubber. And then they'd make it off, which was cutting it into small chunks and popping it into barrels to be transported back to port, where it could be rendered down into oil. So finish making off, cast the ship off from a floe, and set the watch. So there's a mention of ice, flow of ice, so you know they're on the ice edge, because whaling was predominantly an ice edge operation. Stood to the north along the flow edge, middle part, thick hazy weather, dodging at the flow edge, latter part fine, reaching to the southward along the flow, no fish seen, several ships in sight. So they'd refer to whales as fish. They knew they were mammals, but being in the sea, looking like fish, it was traditional. That's the way they referred to them. You can see in the background here what a pay. This is quite a nice whaling logbook, to be fair. But you can see whale's tails. So they draw one every time they catch it, and above the tail, you'd have two measurements. One was the width of the fluke, and the other was the length of the baleen. Sometimes was termed then as whalebone. And that gave you an indication as to how big the whale was. So there's been lots of historical work that's gone into populations, trying to reconstruct population size, and how the whaling industry decimated it. Oh, there we go. So what you might have noticed, and we're coming towards the end now, what you might have noticed is in that daily logbook entry, there was no mention of where they were, which is kind of a big deal. How do you know where the ice is if you don't know where the ship was, and therefore you don't know where the whales were? Thankfully, you can reconstruct the voyages, and it's something that took me a long time to do, and it's going to take me an even longer time to do to all these new ones. But they record their latitude fairly often, so longitude was really difficult to record. The British government set up the Board of Longitude in the 18th century because it was such a problem that we couldn't figure out where we were going. And it wasn't until John Harrison invented the marine chronometer that people could accurately record their east-west position at sea. However, chronometers are really expensive. And as a whaler, why bother? You don't really need to know where you are. As long as you're on the ice edge and as long as you're catching whales, it doesn't really matter. They probably had an octant, which was a precursor to the sextant. They may even had even simpler equipment like a backstaff, because you get fairly regular latitude recordings. And latitude's fairly easy to record. You can take the angle of the sun at the zenith. But longitude's maybe once or twice a voyage, if you're lucky. However, in the Davis Straits, it's fairly narrow, and because of the way the sea ice melts, they're confined to the coast a lot. Therefore, you've got lots of land bearings. And they were here for 200 years. They named most of the land bearings themselves. So I went back, identified them all, and then every time they gave a land bearing, you can record where the ship is, and then you can interpolate between. So this black dotted line here, you've got 2 points. You can interpolate the number of days missing in between. But more often than not, that falls through an island or a piece of land, which obviously can't happen. So my method for adapting this interpolation is to move the point that's on land immediately offshore, and then redo the interpolation to that and then from that, which results in really messy looking charts like this. But it works. I'm really hoping to find out how accurate this is. I've got no baseline because they don't record their position. So I'm joining the tall ships race in a couple of months. And I'm going to do the same thing to their logbook. And Patty's going to kindly transcribe that logbook for me and take out most of the positional information, which is great. So you've done all this. We've figured out where the whales come from. Oh, the whaling logbooks come from. What they contain and what we can do with them. in terms of finding out their position. So what does that show us? So this is some data from my PhD. And this is the July sea ice edge position from 1809 to 1839. So there's 20 logbooks in there that show this. So the solid blue lines are the 81 to 2010 average position for sea ice in this area. And then all the blue splodges are whaler positions when they recorded ice in the month of July. The problem with the lack of data is you can't really look at a single year with a single log, because it may stay in the same place for a month. But if you take a range, so 5 years, or even 2, depending on how many logbooks you've got, and put in all the data you've got for a single month, you start to show an ice edge position, which is really good. So you can see from here that the ice was far more advanced in July than it is in the modern average. And what the data goes on to show is that in August, the sea ice totally melts back in Baffin Bay and Davis Straits. But in the early 19th century, it didn't. So sometime between early 19th century and now, the sea ice totally melted. In fact, sometime between the early 19th century and the early 20th century, it melted, because those Danish charts I mentioned at the start show no ice in August. So that's what I'm going to be doing here at the Arctic Institute. I'm going to be extending this record through to the 20th century. And if anyone wants to help with transcription, as Patty mentioned, I have 140 logbooks. That is, on an average of an 8-month voyage, it's 33,500 days worth of data I need to transcribe, with about 5 data points per day. So I have my work cut out for me. But thank you for listening, and I'll take any questions. Thank you.
Okay, does anyone have any questions? Okay, maybe you could go back to that last image. Right. And tell us, what do each of the splodges, I'm sorry, I'm going to ask you to probably repeat something, but there are other lines around here. So
Yeah.
this is all the modern data, is the solid lines.
Yeah.
And these data show where ships were.
Yeah, and the darker the data, the more observations around that area.
Right.
So it gives you.
So obviously this is where the ice edge used to be.
Yeah.
Oh, I see, okay. It looks like there's a kind of a different pattern as well in terms of the actual shape. Isn't that right?
Yeah.
So, today.
You get an extension of warm water coming up the West Greenland current here. So you can see that's having more of an effect today in melting this area out.
So how did what you did on board that icebreaker influence these results?
Well, I didn't go into that because that's a whole other talk. It's quite cool.
Short answer.
The short answer is you could start to look at more detail in what the ice is doing. So this is ice position, but through converting the terms, so I showed that logbook. Let's go back. And it said flows of ice. That's just one term. They had about 20 different terms to describe different types of sea ice. Some were relating to coverage, like flow and field, and others were relating to thickness, light, heavy. So what I did on the Healy was to use some definitions which were published by William Scoresby, who's a very famous whaler and scientist from Whitby on the northeast coast of England, to make ice observations in parallel with someone using the most modern terms. So now I can look at the age of the ice and the thickness of the ice, and what that begins to show is certainly in the Davis Straits and Baffin Bay that there used to be quite a lot of multi-year ice that lasted throughout the summer and then grew the next winter and lasted. And now that no longer exists.
So is there overlap in the use of terms, say, Scoresby wrote his stuff at what time?
1821 he published.
Right, so really, really early on and
Yep.
Specific to your research period.
Yeah.
So is there an overlap in the terms used, and then you have the term used in modern days along with actual measurements and things? Do you find that?
Yeah, most of Scoresby's terms are still used today.
Right, and so that way you can get an idea of what they mean by those things visually as
Yeah.
well. Okay, and do you find that there's much difference in the use of terms in the different regions of England, or do
No,
basically
it's
in
really,
English they all use the same terms?
it's really interesting. So we've got light airs there as well, which is a narrative description of wind. So there's been a lot of work done on the narrative terms of wind force by a project called the Clywalk Project, which was back in 2005, which looked at Royal Navy, East India Company, and Hudson Bay Company logbooks. And what they found was the wind terminology was the same across all these different institutions, which suggests a linguistic community within mariners. And the same is very true of the sea ice. It doesn't really change across the whole period. I'm really keen to see where it comes from. Scoresby attributes the term field to a Dutch whaler, because they had a lot of interaction when they were up in the Arctic, who said the vast expanses of ice reminded him of the flat fields back at his home.
Oh, interesting. I know that in Newfoundland with the seal fishery, there's a lot of terms around ice because that would have been important for where you were seal hunting, and so old terms are still used all the time today. So even though I grew up in an urban part of Newfoundland, I know a bergy bit from a growler.
No.
And all these different terms for ice. Of course, it's interesting because there's so many icebergs.
They still use those terms as well.
Yes, yeah. So you never ever step on a bergy bit or a growler, but you'd step on a pan.
I'll keep that in mind.
Yeah. Anyway, any other questions? Yes.
Have there been any attempts to use, I know it's following sea ice and travel logs and such, but using archaeological data perhaps to help validate what these logs are saying? Like, I'm sure some of these boats must have stopped at the coast once in a while.
That'd be that's something I'm quite interested to explore, actually. I know there's been stuff done on bowhead skeletons, but that's far older than the whaling trade, going back 20, 30,000 years. But yeah, that would be really interesting. I'm quite interested to explore some traditional knowledge as well, to see if that can help validate what the logs are saying. I have a theory that there's an area in the centre of Baffin Bay called the Middle Ice, or there used to be, which I have a theory that was multi-year ice and was fairly permanent up until around the mid-19th century, and then it breaks up. I'd quite like to, talk to some community, see if there's any history up there, or any stories about the ice changing at a certain time. So.
Okay, Bill first.
Have you looked at any of the American logbooks from Hudson Bay?
I'm going to get those next week.
Sorry?
I'm going to get them next week.
From where?
New Bedford and Mystic. Yeah. I also work with the Old Weather Citizen Science Project, which is transcribing American whaling logbooks from the Pacific. So.
It's quite a limited time period.
Yeah.
It was probably 40 years, 50 years,
Yeah, that's about right.
end of the 19th century.
It'd be interesting to see the differences between the British and the American whalers, because when British whaling kind of died around 1850, Scotland carried it on up until World War I, mainly through the jute trade. But a lot of whalers moved over to America. So there's a few English logs down in New Bedford, which I'm going to get as well. But
Yes. You mentioned that it was a requirement to produce these logs.
Yep.
That if you obtained this government support, you had to deposit a log upon your return. And so I'm just wondering, even as a tantalizing just snippet from
Yeah.
these logs, and so I just wonder, in terms of sort of generic conventions, you're looking at these logs, is there data in sort of what you might call more journals or diaries or letters, and does that information differ from what you're finding in the logs? Are those sources, archival sources for you as well, or?
yeah, actually, so when I was doing my PhD research, I was focused purely on logbooks, but I came across a lot of journals, and because there's so few remaining, I had to look at them. I couldn't use them within my research because of the parameters I'd set, but this time around I'm using as many journals as I can get my hands on as well. So they were mainly the ship's surgeons who tended to be fairly interested in science and natural history, So they'd write down lots of stuff. A lot of them are set out quite like a logbook. So they always start with weather observations, and they'll say about the ice. They'll talk about land bearings, and they give position if it's available. But they'll go into more detail about how whaling was conducted, or the flora and the fauna and life on board, which is really interesting because then that helps me understand what the logbook's saying, because the logbook's fairly regimented in the observations it's telling. So yeah, journals are good. They take a lot longer to transcribe because they're not necessarily, it doesn't necessarily go wind direction, wind force, ice. So.
Thank you. Anything else? We're hoping to find a diary when we go to the US next week to help us sort out where the thermometer was hung on one of Robert Peary's ships. Isn't that right?
Yeah.
Moses
Yeah,
Bartlett's diary. Hopefully he has a few details that can help us sort out some of the strange things we've found in those books. Yes.
Just following up on your comments about Walpole's incentive for whaling.
Yeah.
Have you found, since the time period you're working on is pretty long,
Yeah.
with all the logbooks, were there any other moments of government policy dramatically changing what was contained in the logbooks or the direction that they were taking? And did you, because the decision to standardize it in some ways, it's already one influence of policy on the shape of the records. And so I'm just wondering if there's any way that other policy subsequently is informed by what's actually in the records before it.
No. Yeah. Not really. So the bounty was designed to invigorate the trade and kind of kickstart it. But it ended up kind of upholding the trade for over 50 years before they eventually reduced it and stopped it. But as we're getting into the 19th century, we start using coal gas, and then from 1850 onward, we're starting to burn fossil fuels. So whaling was really, really struggling. And then you've got the advent of steam power as well. So now you've got faster ships and the rocket-propelled harpoon. So now you don't have to go to the Arctic where it's really difficult to survive, to procure this trade. You can now go in the open ocean and hunt rorqual whales like the blue and the minke, and then as Europe did in huge numbers around Antarctica up until the mid-20th century. So there was no new policy that changed, and logbooks themselves were already well established as a maritime document. So before you had sextants or chronometers or any way to measure your position, you could use dead reckoning, which is figuring out where you've been. And you basically, before you have an engine, you're using sails, so the wind and the wind strengths are very important to you. So they were all meticulously recorded, and then at the end of the day, it was usually known as the day's work, the captain or the first mate would go and figure out where the ship had been. And it got pretty complicated in terms of accounting for leeway and drift, and yeah, some of the maths involved way beyond me. I hope that helps.